hopefully can hear me. Okay. Yes, recording in progress. I got it. Get out of here. Okay. Anyhow, tiger beetles I just love them. In the background image right here, butterflies, the beetle world. These are mostly exotic Asian species, but you can kind of get an idea that these things are colored just about every color of the rainbow, and very beautiful patterns on them as well. So they have their own aficionados. Come on. Okay, be that way. Technically, they're the subfamily Cicindelinae of the carabids, the ground beetles. But if you look at the cover of the journal Cicindela here for last December's issue, you'll notice it says devoted to Cicindelidae. IDAE is a family name designation. There are people who insist these are a full family of their own, and that's beyond my level of willing to argue. I'm just interested in the individual species and the relationship to the environment. Worldwide, we've got about 2,300 species and subspecies that have been described. There's a whole plethora of additional varieties based on color variation, but that I think gets to the point of ridiculousness personally. Right now, there are 14 species known to occur in Maine, and I say known as opposed to 14 species in Maine, because when I moved here in 1982, we only had 12 species known in Maine. 2 more have been added, and it's possible we'll see other things, especially moving up from the south as temperatures warm in the coming decades. Most of those here in Maine are 5/8 to 3/4 of an inch long. Okay, come on. Okay, but the keyboard has decided it doesn't want to work. So generally recognizing tiger beetles, they've got what entomologists call a habitus. They have this look about them. If you look in the upper left-hand corner, this is Cicindela sexcutata, one of our very common ones, especially in the spring. And it has the body form with the head and the pronotum significantly narrower than the shoulders of the elytra. Very large bulbous eyes, which is characteristic of daytime visual predators. Other things that we have in Maine that may look like this, and for the uninitiated get confused, the genus Elaphris, like this figure in the middle. This is Elaphris olivaceus. These are also quite pretty, but they're much, much smaller. The biggest Elaphris olivaceus is or biggest Elaphris in Maine is maybe 8 millimeters, so about 1/3 of an inch in length. And that's maybe half the length of the smallest tiger beetle. If you ever get a chance to be out west and you're on a sandy or gravelly riverbank, you may run into a Pistheus on the right in beginning entomology classes. It's what they like to toss for an unknown at the more cocky students, because that's what happened to me. And I said, oh, it's a tiger beetle. Nope, wrong genus. But it kind of looks like it. So you kind of, it's one of those ways they use to knock you down a little bit and say, use the keys and the characteristics, not just what it looks like. But by and large, most of our tiger beetles have the form of this guy in the upper left-hand corner. When you look at the business end of a tiger beetle, the very large eyes of a visual hunter, these lovely mandibles, which is how they got their name, because, just imagine having one of these things that's 3 feet long and having it come at you could be rather ferocious. These mandibles also inject a neurotoxin, and more on that in just a second. But they actually will run out, grab onto the prey, and just ingest it. And then what happens with that neurotoxin not only immobilizes the animal, but the digestive enzymes start actually dissolving the, usually it's an insect of some sort, and actually starts liquefying it's in all of its innards. And so they just suck up the liquid. They're extremely fast runners. And I did find myself wondering as I was working on this, how fast are they? Over 5 miles an hour. The world record is, I think, 5.6 miles an hour for an Australian species. Most of those we have here in Maine, 4.5 to 5 miles an hour. Put that in perspective. That's about how fast most of us would walk. So these guys, and they're only, 5/8 to 3/4 of an inch long, they're running as fast in a second as one of your strides. So they do very, very well. That neurotoxin I mentioned, this is Omastagani. It's a Pacific Coast species. Friend of mine had one of these as a pet, kept her in a small container and fed her regularly. And he handled her a little bit roughly one day. And in her frustration, she bit him on the thumb. His thumb went numb for half an hour. And then his entire hand tingled for an hour to an hour and a half after that. That's how strong that neurotoxin is. And this is from the it may look gigantic, but these are about an inch long. And they are actually, they're flightless. I'd love to introduce these in southern Maine, but I know there's all sorts of ethical and legal reasons why I couldn't do that, but they might survive down on the south flank of Mount Agamenticus or something. And they're really awesome beetles. Got to look at the biggies. What are the biggest tiger beetles? The genus Manticora in Africa. These get up to about 25 millimeters long. That is, 50 millimeters long, 5 centimeters. That's 2 inches. Depending on whose classification you believe, there's anywhere from 5 to 13 species in this genus. Rather nasty mandibles on them, but fortunately we don't have those in Maine. And you ask, what do tiger beetles eat? It's dang near anything that comes along. Manticora, this is a Manticora with a frog, rather hapless frog. And unfortunately, something that worked always when I was teaching and does not want to work here is a hyperlink. But if you go to that link in the upper right-hand upper portion of the screen, for me, unfortunately, about 3/4 of that is blocked out. But that link at YouTube will actually get you about a 1-minute video of a Cicindela sexcutata. And at first it looks like it's just sitting there, which it is, but then it starts to move. And then you can actually watch it ingest a fly that it has caught. Does very well. And it just munches and just pulling it in. And you see the fly disappear, and then it spits out this wad of just the skin. Everything else is gone, which is pretty awesome little video how they got that. So tiger beetles are holometabolists, meaning they have, like most other insects and all beetles, an egg and larval stage, and then a pupa and the adults. Most Maine species are typically 2-year life cycles, so they will spend a year and a half, maybe, possibly up to almost 2 years in the larval stage, come out as adults. The pupal stage, it only lasts a couple of weeks, but they go from the larvae to adults. And then, of course, once they're adults, they're running around eating, trying to find romance before they themselves get eaten. And we'll look more at predators on tiger beetles later. But they are pretty fast guys on their own. One of the things that's characteristic of tiger beetles, first off, they're on almost invariably very open ground. There are tropical species that are up in the tree canopy and this, that, and the other. I know nothing about those. But those that we have here in Maine, like open ground, depending on the species, you may find them on clay, you may find them on silty, fine sand, you may find them on sand and gravel. And this all comes down to the form of the ovipositors of the females. Those that are found on sandy substrates tend to have very blunt, short ovipositors, and those that are found on clay tend to have very elongate ovipositors, which are needed really to actually put a hole down into the clay to lay the eggs, so that the eggs are protected in the subsurface. Because all the larvae of tiger beetles, at least those that we have in Maine, live underground in burrows where they basically are ambush predators. They just stay there and they wait for something to come along, they grab it and they eat it. This is Cicindela duodecimguttata, which is one of our sand. Go away, go away, go away. Sorry, cat bothering me. But it's one of our sandy substrate species. The burrow on the lower left is an ovipositor oviposition location, where an egg is actually, in this case, in the lower case, in a very fine sand, almost silty substrate, but actually laying the eggs. This is a European species that prefers the more clay-rich substrate, and at least there, the photo in the lower right-hand part of your screen, you can actually see the tip of a mechanical pencil, which will give you an idea of the scale of these. They're very, very small. And as the larvae eat and grow, molt into successive instars or later stages, you'll have 3 separate larval stages. They actually will enlarge the burrows. So you can see first, second, and third instar burrows here with a fingertip for scale. And this is an example of how a couple of third instar larval burrows might look if you actually find these in the field. This is in a kind of a little bit of a muddy sand substrate. And the larva in the burrow on the left, got spooked and dropped out of sight. And the one on the right-hand side, which kind of looks like a bristly garbage can lid, is just sitting there and waiting for something tasty to come along. And it's very hard to actually study these while you're in the field, because they're very sensitive to any vibrations in the surface soils, which is how they detect prey. It's very, very subtle movement that they can actually pick up just from the feeling of that in the substrate. So what is one of the great accomplishments is to actually be able to sneak up on one of these and get a large knife blade or a trowel underneath them and flip them out onto the ground surface before they actually escape, because some of these burrows will go down 6, 7, 8 inches. But when you flip them out, this is just another one that's waiting for prey to come by. Okay, waiting for the next meal. When you flip them out, first time I saw one of these, the impression I had was, wow, does that ever look like one of those Chinese dragons where they get, 10 to 20 people underneath and it does the big wavy thing, coming through at Chinese New Year and everything else. So you can see, let's see if the cursor, you've got the mandibles out here in the front, which are what you see up here in the upper photo. And one of the things that I didn't understand at first until I figured somebody was telling me what they're used for. And actually I saw another diagram, but you've got 2 hooks on this, I think it's an 8th abdominal segment back here, that are hooked forward. And that doesn't seem to make a lot of sense for something that would be moving forward until you see how these things are set up in their burrow. And you can see down here at the bottom how these hooks are arranged such that if the larva grabs something that is comparable to its own size that otherwise risks pulling it out of the burrow, it can dig these in kind of like anchors and keep itself ideally from being pulled out of the burrow and potentially eaten itself. But then that helps it also to then whatever prey it's got, maybe it's an ant or maybe it's another larva or like grub of some sort, and then it just pulls them down into the burrow and eats them and just continues on its merry way. When we look at the total fauna that we have here in Maine, Cicindela marginipennis, it's the newest addition to our fauna. Jonathan Mays and Mark Ward found specimens of these on a river here in central Maine back in 2007. It was worth a paper in that journal Cicindela we saw at the very, very beginning. every place that this is known in the northeastern US and adjacent Canada, it is considered to be at extreme risk. And this is because these are found only on gravel bars in large rivers. And what has happened to virtually all of the large rivers in the northeastern US and adjacent Canada? Oh, we put dams on them to create reservoirs so we get lots of clean hydropower. But what that does is what that has done is pretty much wipe out the habitat for this particular species. So where it is found, it's invariably protected. I don't know that there's any official protection status for this yet in Maine, but I'm sure it'll come around eventually because, like I said, only one known locality. Second species that's also of concern for the state in Maine here is the white mountain tiger beetle, which is Cicindela encosisconensis. And you'll notice that on a lot of these, the maculation patterns are quite different on the elytra, and that's generally one of the easiest ways to tell the species apart. This one has what's called the humeral lunule, in other words, a C on the shoulder. That is a broad C that where'd that pointer go? Okay, it decided to fade out. That starts at the shoulder and then hooks back and is almost diagonally pointed across the elytra. There's another very common species where it comes in and hooks around. But this was first described back around the, I think, 1852 or so from the White Mountains. And it's known, if you look at the maps, I've got maps for most of these species. This is Strong, which is just north of Farmington. And then I believe in Gilead, and then in, whoops, where'd the pointer go? Then Freiburg down here. So we've got those three localities, the only places where this species has been seen, not to say it's the only place it occurs, but those are the only places it actually has been documented in the state of Maine. The third species in Maine that's of special concern is Cicindela marginata. And what's really cool about this one is when you look at the central portion of the elytra, it's got this really tiny, complex, squiggly line that goes through here. And this is found only in salt marshes along the coast. I believe it has been found at the mouth of the Kennebec in Phippsburg, and then multiple other sites down along the southern coast down into Wells and I think Ogunquit as well. And unfortunately, the cursor keeps cutting out on me down here, but down here on the southern Maine coast. And I actually was down in Wells a couple of years ago. They asked, they asked me if I determined whether this is still there. And despite its name, it's the salt marsh tiger beetle. Where I found it was not where it had been described as occurring before on the exposed salt flats or sand flats below the salt marshes at low tide. The only thing I found there was another common coastal species, but where I found it abundantly was places like this, where a storm had ripped out the turf in the salt marsh. And on this one little area right here, there were probably a couple hundred of these tiger beetles. Because they're so fast, they just sit there and they wait for, if you've ever gone into a salt marsh in the summertime, you get flies all over the place. So they just sit there and wait for a fly to land, and then they just pounce on it and eat it. And that's all there is to it. And I was asked, well, what can we do to improve the habitat? And I basically said, don't let the do-gooders come in and try to reestablish your salt marsh vegetation on these flats like this, because that is the habitat for the beetle, as far as I saw when I was down there. That was the prime place where there were many of these things, not only here, but also where storm waves had thrown tremendous amounts of beach sand up on top of the salt marsh and partially buried it. That was another good site, but open ground again, always. This is the six-spotted tiger beetle, the bright emerald green one that is probably, if any of the tiger beetles are familiar to people who get out and about, this would be it. These are out very early in the spring. You'll find them at the forest margin. They'll be on paths, generally fine sand to, decent soils, if you will. But again, open, bare ground. And these, because they're so brilliantly colored, will stand out and be quite visible. What I didn't mention earlier in talking about how these are visual predators is the fact that that also makes them very difficult to approach. Generally, you're not going to be able to just walk up within 5 or 6 feet of a tiger beetle before it either runs or flies to escape you. So catching these takes patience and stealth. And I know one of the things among beginning entomology students, it's always a challenge, is can you catch one of these with your bare hands without a net? It's not easy, but it can be done. It does quicken your reflexes. So this is found pretty much throughout the state. Very, very lovely. There have been attempts to name a particular subspecies for specimens that are more blue than the green. But since it's a continuum, I don't think that's gone very far. Cicindela duodecimguttata. This very similar to the Anca cisconensis, but you'll see, if you notice, this C on the shoulder does not go diagonally across. Okay, where'd the cursor go? Does not go diagonally across, but actually comes down and hooks up. So it's almost pointed straight across. This is one of our most common tiger beetles. I think Wilson and Brower did a paper in 1982 with tiger beetles of Maine. When I moved back here, a friend sent me a copy of that and said, work on this. Okay, excuse me. But what they said about this is you can find this on virtually any logging road and in any gravel pit anywhere in the state. So very, very common. But again, not easily seen because they're brown against a brown substrate typically, and you're not getting very close to them. And late in the summer in particular, when you see something running or jumping and flying, oh, is that a tiger beetle or is that a grasshopper? Good question. Sometimes you've got to snag it out of the air to find it. Cicindela tranquiberica is our oblique-lined tiger beetle. Variable in color. I've seen brown ones. I've seen greenish ones. This is kind of bluish. Again, found throughout a lot of the state, generally on sandier substrates. Quite pretty, fairly common. Excuse me. All of these things eating basically whatever happens to come along, generalist predators. Cicindela scutularis leconti, the festive tiger beetle. I love these names. This was one that Wilson and Brower said should be in the state of Maine, but we have not seen any specimens. There's a handful of us, Dana Michaud and Dave Burke did a lot of collecting. I found it. Some other people have also found this in Maine. And what really makes this one stand out is when you look in the middle of the elytra back here, you've got a triangular field that just sticks right out. And we've now got that all over, multiple sites. There are other sites. These maps all date from, basically the data is from up to about 2000 for most of them. But it's pretty much throughout the southern part of the state on nice sandy ground. Cicindela formosa generosa, the big sand tiger beetle. This is our biggest species. Very broad maculation patterns on the elytra. You'll find this along the coast in the sand dunes where you've got discontinuous grasses or sedges. Not completely clean sand. You want a little bit of grasses and sedges, graminoids coming up, and you'll find it in that kind of habitat. Technically, they get up to about 20 millimeters, 4/5 of an inch. But when you pick up one of these, it's like, wow, that's an inch long. Well, not when you actually measure them, but they are big compared to the other tiger beetles. The other one on the coast that's commonly associated with that on the coast is Cicindela hirticalis. This is the hairy neck tiger beetle. You'll get this pretty much along the Maine coast, a little farther up the beach and on cleaner sand in the dunes than the Formosa. This guy does not like the vegetation starting to poke up through the sands. And this is the one that was when I was looking in southern Maine for the salt marsh tiger beetle down on the sand flats that were exposed at low tide, which is where I'd read, oh, this is where you'll find the salt marsh tiger beetle. This is all I found was this guy down on those areas. But the photo that was on the cover of the journal Cicindela back at the beginning was a different subspecies of this that is considered threatened in Washington state. It's a bright green one, just a color variant, but it's also Western population. Cicindela punctulata, the punctured tiger beetle. This is our littlest guy, only found in the southern part of the state, generally on very packed, silty, fine sand substrates. But it's this is a species also found transcontinentally, but you've got a whole line of punctures on each side of the midline of the with both of the elytra. And when you look at it, it doesn't show in this picture, but typically when you look at these very closely, each of those punctures is kind of metallic blue, but it's on a very tiny scale. Come on, you stupid pointer. Anyhow, but this guy is only about 5/8 of an inch long, so maybe 14 millimeters or so, quite small. Other subspecies, this is punctulata. Other subspecies that I've seen from out west, they're kind of metallic blue or metallic green, really quite pretty, but very tiny. Cicindela lumbalis. This is one of our common, it's called the common claybank tiger beetle. This is arguably one of our prettiest because they can vary from this brownish to almost a purplish, but bright green along the margins. You'll find this on clay-rich substrates and silty substrates. If you go into some of the sand and gravel pits, where on the sandy substrates, you'll find Cicindela duodecimguttata, or maybe Cicindela rampanda, and then you go across where they've quit excavating because they ran into a lot of clay, and you'll find these guys on the clay. So you can sometimes get, 3 or 4 tiger beetles in one small area. This is Cicindela purpurea, the cowpath tiger beetle. This is another one that likes clay-rich substrates. That's a pin specimen, unfortunately, and that looks like a Frank Guarnieri photo, if I'm not mistaken. Just the pinning job and the meticulous care that was done there. For those who don't know Frank Guarnieri, he is an MES member who unfortunately works Thursday, Friday, Saturday, so he can never participate in any MES events like field days or the annual meeting or anything else, but very, very active and does these meticulous pinning jobs. He lives in Waterville. Cicindela longilabris, the long-lipped tiger beetle. This is a conifer forest species, generally on sandier substrates. I've never, well, it's found throughout the northern half of Maine. I have seen photographs from down in this area, from Vienna, top of Vienna Mountain, Vienna or Vienna. Take your choice. Come here. Where are you, little? But from the top of Vienna Mountain, just over near Belgrade, I've seen a specimen, a photograph there. That's the southernmost record that I know of in the state of Maine, but it's found from there north, and it's found transcontinentally. Here in Maine, it tends to be brownish to almost black in color. What distinguishes this when you look at the face is that the labrum, basically the upper lip, is twice as long as that of any other tiger beetle. So it's longilabris, the long-lipped tiger beetle, goes way down. Specimens that I collected on the West Coast in Oregon, up at around 3,000 feet, were bright emerald green. But still showed the same maculation pattern on the elytra and still showed the very, very long labrum on the front. Ooh, and I left out Cicindela repanda, and I am sorry. Looks very much like Duodecim guttata, very common on riverbanks. Whoop. Nope. Thought someone was asking a question. So question is, one of the things, if tiger beetles are so fierce, do they have enemies? Well, Mathoka is a wingless little wasp. It's a parasitoid on tiger beetle larvae. And I actually collected one of these on an MES field day in 2018 when we went out to Bering to the Moosehorn National Wildlife Refuge, and there was an old sand pit that was just chock full of Cicindela tranquibarica, and I thought, whoa, look at this weird ant. So I picked it up and brought it back and described it to Dana and Dana Mishu, and Dana said, oh, that's Mathoka, they're parasitoids on the larvae. Whoa, it's okay. And I found a good sketch, and then I, on a whim, went to Bug Guide, my favorite source for photos, and Brandon Wu took one of these. Brandon's one of our members. I think he's watching us, but maybe not. I know he was going to, but this is from right here in Maine. That's so 8 millimeters is about 1/3 of an inch long. Diptera, robber flies, the acyllids. On the ground, these are no match for the tiger beetles. The tiger beetles can run much faster, but when the tiger beetles get scared, get up into the air, these guys can go after them, can actually predate on them, and actually have also been known to take away their prey. And of course, then there's other things like, spiders, dragonflies, birds, frogs, small mammals. They're all happy to enjoy munching on tiger beetles because the tiger beetles are very active during the daytime. If it's at all chilly, like overcast, one of the places I have found some tiger beetles is under bark, loose bark on big logs on an overcast day, because they will hide there, or they will actually go into burrows underground and actually hide out as well there. So there are things that will feed on them. And I meant to go back. How long do tiger beetle adults live? Typically 1 year, maybe. But I have seen specimens from here in Maine that are very, very scraped and scratched up that probably are like 2 years old. And that Omastagani, the one that bit my friend on the thumb and his thumb went numb, that because she was protected, he just had her in a small terrarium and fed her regularly. She lived to be 5 years old before she eventually went to her demise. So, that pretty much covers it. Are there any questions? I see on chat 7. Whoop, now I got to put my glasses on because otherwise I can't read. Okay.
Can you see the chat box there, Bob? Or do you want me
yes,
to
I
read
just
it
brought
to
it up. Are those seedy above the eyes? Okay, the frontal image. Actually, yes, they are. And in fact, the seedy are very, very sensitive. I mean, you just think of hairs. No, but those individual seedy that were above the eyes, sticking up there, very sensitive to any air pressure. So if they get the scent of potential prey, the direction the wind is blowing those seedy tells them what direction that scent is coming from, so they can turn and look right at it. Does the female lay just 1 egg per burrow? I do believe they do. How many eggs? Generally among carabids, I think it's 100 to 150 per female, sometimes more. The rather sad thing about it is, just imagine having to have 150 kids to hope that 2 of them survive to adulthood. It's a pretty grim reality when you get down to it. Okay. Why do you think the adult stage can last so long? Well, the sad reality is in nature, there's almost no animal that dies a peaceful death in their sleep of old age. Basically, they keep going until something eats them, or something else kills them anyhow. But one has to bear in mind when you're looking at invertebrates like this that are exothermic, almost everything that they eat goes into either growth, reproduction, or muscle action. They're not wasting heat, wasting energy generating body heat, which is about 90% of what happens. 90% of the food that we eat, if we're maintaining a constant weight, goes into just maintaining body temperature. Hope I answered all the questions. Oh, does the long-lipped beetle use it for a particular feeding strategy? I don't know what the function of the labrum is in terms of why a long one would be better for feeding. I would think it would get in the way, but there's got to be some reason why it has that. In the Midwest, the variety that's completely black, when I was a student, we were told it was Cicindela nebrascana, different species altogether. And now, I guess DNA work has shown it's just a black color variant on the long-lipped tiger beetle, but no idea exactly why. So did that answer the questions? I don't know even what time it is. Whoop.
7:40, so we got plenty of time. That answers the questions in the chat box. So at this point, if there are folks that have a question that didn't put it in the chat box that would like to open up their microphone and go ahead and ask Bob directly, that's quite fine. And then, yeah, if things get out of control, we'll use the raise hand feature. But for the time being, if anybody has any questions, go ahead and unmute and see if you can be the first one to grab the microphone.
Hey, Bob, this is Jim Labonte.
Oh my God. Now I'm
I
busted.
really enjoyed your presentation. I got here a little late though.
Oh, thank
Anyhow,
you.
I wanted to let you know about Cicindela herdicolis siuslaiensis that you referred to.
Okay.
The Washington supposedly T&E thing.
Yep.
I've been doing a lot of work on that. It really differs from the others, especially the inland Cooleensis, mainly by ground color and also slightly smaller maculations. This is almost certainly meaningless because they've demonstrated for many species of tiger beetles that those sorts of color variations are often based on environmental factors, such as is it a cooler climate, is there less sun, etc.
Yeah,
Cooler climate and less
during
sun sort of
pupation.
describes the Oregon and Washington coast.
Cool.
All right, any other takers out there for questions? I guess I'll go ahead and ask one, Bob. You
Sure.
know, they're obviously very colorful beetles, but you know, here in the Northeast, at least, you have that kind of common colorway with that purplish brownish backdrop. You know, with the lighter colorations aside from like the six spotted that's metallic. So, is there any thoughts on the specific, you know, evolution of those colorways? Is it specifically just substrate, or is there anything else to that?
I suspect a lot of it is just camouflage against the substrate. If you're trying to chase down Cicindela sexcutata, for instance, and you know it's running along and it decides to fly, it invariably flies into, at least in my experience, flies into vegetation and drops. And you're looking in, you know, a lawn for a green beetle, you can't find it. But the others are running around and actually, when they land on a substrate and they remain absolutely motionless, they're usually perfectly camouflaged in that particular substrate. The ones on the clays, the marine clays that we get along the coast here in Maine, Pleistocene, Presumpscot Formation clays, when those start to oxidize, when they're exposed and just start to oxidize, at first they're gray, and then they start to get a little bit brown and a little bit of sometimes some green, because you'll get some mold growing in there. So you get this mottled coloration. And as long as they're absolutely motionless, they're quite hard to see. But the thing is that if you walk into the area, and it's kind of like stalking deer, you take 1 or 2 steps and stop, take another step or 2 and then stop. And then you can see them running to try to get away from you. Oh my goodness, there they are. And they're all over the place. But you've got to be patient. If you just walk through, they just take off and go in every which direction, and you can't see them. But once they land, if they remain motionless, with that coloration pattern, they're pretty much invisible.
Very good, thank you.
Okay, the larval form of the salt marsh. I don't think when you get up into the salt marsh, where they're living, I don't think that's inundated by the tidal fluctuations. I think that's entirely a result of the only time they really get hit with inundation is during storm events. And I don't know how they survive through that. There are a lot that will actually have an air bubble around them just because of the surface tension of the waters. I find it, kind of like one of those things that makes you wonder how, with all the salt that's around, do they not wind up becoming dehydrated? Why doesn't it pull the moisture out of their bodies? But I don't think they get inundated twice a day up in the salt marshes. There are beetles that live in the intertidal zone. There's a few of them, and I know we have one that's supposed to be here in Maine that actually they actually do go down like in the cracks in the rocks where there is a little pocket of air, because the crack is so narrow, the air bubble in there remains during the inundation of high tide. And then when the tide goes out, then they can come out and emerge and run around and find something to eat. And then as the tide starts coming back in, they go back down in between their cracks, in their little cracks in the rocks. So hopefully that answered that. And this is from Holy Grail tiger beetle. Oh my goodness, I'd like to see one of the marginipennis. Of course, the problem is you got to catch it to see it. So you got to catch it, get it in the net, and then, look at it, and then okay, that's what it is, and I'll let it go now. But I haven't seen one of those.
Brian Pfeiffer.
Pardon?
Brian Pfeiffer here, if I may, on netting. I'm wondering if you have a preferred method of netting these beasts. Pancaking, for example, if the substrate allows, versus what I try to do, which is flush, lunge, and sweep just as they're taking off. I don't know whether you found, have some strategies on getting them in the net.
You're faster than I am. I've actually used both. I tend to be more of a pancaker these days. Try to see where they are, and then slap the net down and make sure it's sealed all the way around. One of the things that I have found is it does not appear that tiger beetles are quite as common as they were when I first moved to Maine. I can remember running along a sandy riverbank in Norridgewock on the Sandy River, ironically. Oh my goodness, back in the mid 1980s, and there were so many tiger beetles. I just ran down the sandbar with my net at my side. And when I got to the end of the sandbar, I folded the net over, and it had like 15 or 20 tiger beetles in it, because they were there by the hundreds on the sandbar.
Wow.
But as far as the actual efficiency, I think it varies for these things, and certainly that cobblestone tiger beetle, trying to get a good seal with a pancake method on gravel that's 2 to 4 inches in diameter is going to be just about impossible. Does that answer your question, Brian?
Yeah, thanks. I'll just add one quick one is that Ross Bell, I believe, once talked about using a fishing rod with a big Coke bottle with like half of the bottom of it cut away, and that you would sort of extend the fishing rod out over the tiger beetle and then lower the Coke,
Yep.
the plastic bottle over it. I was wondering if you've ever done that.
I've seen Ross do it. I think once I saw Brandon Wu do that to get beetles that he was trying to photograph. But if Brandon's on, I can't scroll through and see everybody who's on right now. But I think Brandon did.
Yeah, at the very least, it would be fun.
Yeah, but it would be. I tend to keep my fishing rods for other things, but
Yeah. Okay. Thanks a lot.
sure. Hi, Brandon. Yeah, see Brandon. Okay.
So Brian, excuse me, let me interject. This is Jim Labonte. On some of the playa areas in Eastern Oregon, what I do is when there's a nice stiff wind, which is pretty common there, I will chase them into the wind, and that will slow them down enough that you can aerial net them.
Yeah, that's great. Yeah, I'm wondering if you could even put him into a stall and get him.
Well, when you think you've got them, in my experience is when you think you've got them in a stall, what they do is go sideways. And then, it's kind of like grabbing at that hockey player who's got the puck and you go smashing into the boards and he's gone.
Yeah.
So, and River Santino wanted to know if I can tire one out by being persistent and chasing it on the beach sometimes. But the hard part that I've found there is keeping track of the exact same beetle to keep chasing it, because it lands and then, okay, I'm creeping up on this area, and then there are 5 that all take off from that same location. So it's like, wait a minute, which is the one I was chasing? So it can be difficult, but running them down on the beach will work. Along rivers is much tougher, and especially for the ones that disappear into vegetation, it's pretty much impossible. Oh, and Brandon has asked, hopefully that answered that question. How do we wind up with so many superficially similar tiger beetles with similar feeding habits, all inhabiting very different habitats? Well, there is some overlap. And I think one has to bear in mind too, that Maine has only been deglaciated for about 14,000 years. And these species probably have much greater longevity and very likely evolved in different areas and then are overlapping. And in terms of very different habitats and, the subtleties of the substrate can be really critical. When I first started collecting in Maine in the 1980s in Fairfield, I think in one area, and Jim Labonte and I wrote a paper on a couple of these, but in one area, I think that was maybe 100 yards by 100 yards. I got 7 different species of tiger beetle, but on slightly different substrates, and one was more shaded than another, and one was silty and more clayey, and another was partially like sand dunes, that sort of thing. How they find a mate. How do they find a mate? I think it's a lot of it certainly is by pheromones released by females. And how it was described to me when I was a student, and I had no basis to argue the case, is that the setae that are on the antennae are so sensitive to sex pheromones, is that they can take, basically a male can detect a female who's, within, shall we say, striking distance, and detect the level of that pheromone in the air at the equivalent of our being able to taste the sweetness of a teaspoonful of sugar dissolved in an Olympic-sized swimming pool. That is how sensitive they are. It only takes like 6 to 10 molecules of that pheromone to hit the antennae for the male to recognize that there is a female nearby. Excuse me. Okay, Kathy, do you try to find new species or species not yet seen in Maine by looking at unexamined habitats? Or do you just always have your eyes open? I try to do the latter, but there are certain things basically I don't spend a lot of time in the forest because I figure the Maine Forest Service has sampled that about as extensively as anybody possibly could. I spend an awful lot of time, and those who've been in the field with me know I'm really happy when I'm in like a foot of water at the edge of a marsh. And it's kind of funny every time I go in for an annual physical and the doctor asks, well, are you having any trouble with stability issues and falling? And I think, oh yeah, well, last week I fell, but wait a minute. That's when I was in a beaver pond and stepped on a log underground and lost my footing on the mud, and went down and splashed, but that's about it. So I'm focusing mainly on wetland environments where basically we did not have an awful lot of coverage previously. The tiger beetles, that's kind of by hook and crook. I haven't personally spent a lot of time trying to collect tiger beetles. I'll grab them when I can. But lately, I'm spending an awful lot of time on my hands and knees with an aspirator in my mouth, going for the little teeny tiny things in dry habitats. And was out a couple of weeks ago and actually got a couple of specimens of a species that I think we had previously 7 or 8 records in the state of Maine. But not a lot of people get on their hands and knees and grub around in gravel pits looking for things that are 1/12 of an inch long. But they're fun. Is there one environment that attracts the most variety? And courtship, wow. I would guess probably actually a sand pit. If you've got a muddy area in it, you might get as many as 4 or 5 species in that one sand pit. As I said, the subtle differences in the substrates can make all the difference in the world. Just going from a wetter to a drier substrate on the wetter muds. You may actually find, especially if you've got forest right above the sand pit, you may find Cicindela sexcutata, and over in the dry sand, you'll find Cicindela rapanda and Duodecim guttata. And then over on the clayey areas, you might find both, oh my goodness. Drawing a complete, the claybank tiger beetle and the cowpath tiger beetle as well. Hopefully that helps. But the only way to find out what's out there is to go out and excuse me, if you've got if you can get close enough to get a good photo, then that's really great. I tend to believe in the collecting, but because that's kind of the gold standard, and everything that I collect, if I find anything that's I think is cool, I'll go ahead and collect it. And the carabids I keep for my own collection, and the other specimens I pass to Dina Mishu, who then puts them all in the Maine state collections down in Augusta. So at least the specimens are documented down there. So let's see. Oh, the coolest thing that beetle parts helped you figure out about prehistoric times. Well, sometimes it's what everything we knew is wrong. But when you look at the areas in which many, and I worked only with beetles, but you tell a geologist you work with fossil beetles, and they say, okay, well, what else do you do? And you tell an entomologist you work with fossil beetles, they say, what family, what genus? And you say, well, I try to do them all. So it gets a little crazy. But I worked on a site here in Maine when they were building the new, I think, Mercy Hospital down in Portland. They found what turned out to be a major old late Pleistocene landslide deposit that came down into the edge of what was then the Atlantic Ocean. So it brought down this whole forest complex that was down there. And when you look at the plants that were in the in the assemblage. It was almost entirely white spruce, and they were very stunted white spruce. Some of them were stunted, some of them were fairly healthy, but it was clear from the rings that they all died in the winter. So this came down, or winter or very early as spring. But when you looked at the plant fossils, which was white spruce and quaking aspen, so I think there might have been one black spruce in there, and the mosses and everything else in the plants said that it was an environment, when that came down, the environment in the Portland area was similar to modern day Labrador. When I looked at the insects that came out of the assemblage, that came out of the same, there was a buried forest floor deposit. Everything that was in there for beetles could be found within 50 miles of Portland today. And so that kind of changed our interpretation of what the actual climate was at that time, because obviously, if a spruce tree isn't happy where it's growing, it's stuck. If a beetle isn't happy where it's living, it gets up and leaves, because they can virtually all fly as adults. And so the insects tend to be much more responsive to climate change than the vegetation is. The vegetation has a lag involved. And I think Brandon Wu has also already found several species in southern Maine where I don't get down to collect very often, but several species, including a carabid, that were never seen this far north before. We are starting to see more southern elements moving into the state from the south. But without knowing what's here now, we have no way of knowing what the change actually is. And so that's why.
Even at the crusty old age of 70, whatever.
I still try to get out and collect whenever I can. And I'm also right now trying to catch up on the backlog of hundreds and hundreds of specimens I've got downstairs that were collected and need to be pinned. Some of those that I've pinned in the last year, I collected in 2008. So trying to catch up with the backlog, but being able to figure out past climate.
Great. Well, thanks, Bob. So we've passed the hour mark here, so I'm going to wrap things up. But again, thanks so much, Bob, for a very interesting presentation and some very interesting answers to some great questions. Thanks everybody as well for tuning in. I believe we'll be back probably November 18th. That's a Thursday at 7 p.m. at the same time with our next installment of this webinar series. Presenter and topic to be determined, but keep an eye out for advertisements. And then as far as this webinar, this will be recorded and eventually it will be uploaded to the MES site. So if anybody needs to find it, it will make its way up there eventually within the next couple of months or so. So with that, again, thanks everybody and take care.